nearly 3/4 of the Earth's entire surface is water. Since early in the history of man, surface ships have sailed the 7 seas. It is only recently, however, that man has been able to travel successfully below the surface of the water. In ancient Greece, Archimedes had already discovered most of the principles by which we now operate submarines. Archimedes' principle, also known as the law of buoyancy, states that if an object is entirely or partly immersed in water, its weight appears to be reduced by an amount equal to the weight of the water it displaces. This means that an object has a certain weight when weighed in air. But the same object, when weighed in water, always registers a reduced weight on the scales. To explain this principle, let us imagine the water to be divided into horizontal layers. The weight of the water in layer 1 presses down on layer 2. Layers 1 and 2 together press down on layer 3. And so the pressure steadily increases as we go deeper. When an object is submerged in the water, the various layers press against the object with a force equal to the weight of the water above. Thus we see that the pressure on the object is weaker in the upper half and stronger on opposite sides of the object are opposing each other. Therefore, they may be subtracted to find the net result. When this is done for the entire surface of the object, we can see that the upward forces overbalance the downward forces. This net force is called the force of buoyancy. It is acting upward in opposition to the weight of the object. Here we have 3 objects of equal size but of different weights. Since they displace equal amounts of water, their buoyant forces are alike. This object made of steel weighs more than the water it displaces. Therefore, its weight is greater than its buoyant force, and it will sink. This is called negative buoyancy. But if the object is made of water, or some material of the same weight as water, the buoyant force just balances the weight. If not disturbed, it will neither rise nor sink. This is called neutral buoyancy. If the object is very light, for example, a sphere of air, it is lighter than the water it displaces. It rises and floats at the top of the water. This object has positive buoyancy.